in joules per photons, second, electron volt per photon, kilojoule per photon, and kilocalorie per photon. Okay. And then second, we have to find the frequency, and the third, we have to find the wavelength. Okay. So how will you able to find this one? So we have a formula that energy is equals to hc by lambda. Okay. And it is also equals to h nu. Okay. Because c by lambda is frequency. Okay. Got it? You understood? And
Yes,
E
sir.
is also equals to h c into 1 by lambda. 1 by lambda is actually wave number. Okay. Where this is wave number. Which is also equals to 1 by lambda. Okay. You understood?
Yes, sir.
The formula will be the for formula, because in terms we have given the wave number. Okay. So it is given that the 10-second inverse is the formula for this one. Okay. So wave number is actually, if something is given to you 10, 10, this is the wave number. Just a minute. Okay. So if something is given to you 10, or we can say if the wave number is given to you 10 centimeter inverse. 10, okay, 10 centimeter inverse. If the wave number is given. So it is a reciprocal of this one. Okay. So if I want to convert, like for example, if I need to convert centimeter into meter, what you actually does? Tell me. You know that 1 centimeter is equals to, or we can say 100 centimeter is equals to 1 meter. Okay. Got it?
Yes, sir.
100 centimeter is equals to 1 meter. Or we can say that 1 centimeter is equals to 1 by 100 meter. Okay. Got it? And if I having this 10 centimeter, then it will be equals to 10 into upon 100 meter. You cut it, you will get 1 by 10 meter. Means 10 centimeter is equals to 1 by 10 meter. Okay. Got it? But actually,
Yes.
since it is in centimeter inverse, so you need to note it down that 10 centimeter inverse is actually when we are just having inverse unit. Like for example, we have 1 centimeter is equals to 1 by 100 centimeter. Sorry, 100 meter. Okay. So if it is inverse of this one, so just write it. Where we are just multiplying, we have to divide it, and when we have to divide, so we can write it. If I write this 1 centimeter inverse is equals to 100 meter inverse. Okay. You have to write it. If it is inverse, then this will become inverse. Okay. This will become reciprocal. Got it?
Yes, sir.
If I got this one, 10 centimeter inverse is equals to 100 meter inverse. Okay. If I multiply by 10, you have to multiply this one also by 10. Got it? Should I explain you one more time?
Got it.
Okay. Now here it is given to you that because why we are just converting this one into meter inverse, because the standard unit of wave number is meter inverse. Okay, not the centimeter inverse. So we have to convert it so that we can convert it into. So 1 by lambda is actually the value of 1 by lambda wave number is actually given to you, that is 1000 meter inverse. Okay, got it. So here we have E is equals to hc by hc by lambda, and lambda is actually wave number. So here h is 6.6 6.6 into 10 raised to the power minus 34 into velocity of speed of light is 3 into 10 to the power 8 meter per second into this will be 1000 meter inverse. Okay. So if you multiply all these, what you will get? You will multiply this one. Okay, other unit is not there, so you will write 6.6 into 3. So what you are going to get here? Tell me. 6 to the,
19,
yeah,
19.8.
18.1 carry 6. 3s are 18 and 1 19.8. So you write 19.8 into 10 raised to the power. What you will write? 8 and 3, 11. 34 minus 11, what you will get?
23.
23. Okay. That will be 23 minus of 23. Got it? Or
Yes.
19.8 can be approximately equals to 20. If it is the question is given to you, 20 into 10 power minus 23. And okay, and this will be equals to 2.0 into 10 power minus 20. If you are putting the decimal one place before, so it will be 22. Got it? Got it? And the same question, this question Planck's from means so many questions is being asked in the Planck's quantum theory. So you must be familiar with all types of question that is being asked, because these are the types of question. Okay, there are 4 to 5 types of question that is being asked. We are all going to do that all. Okay, so here we have 2 second. Now you have to tell me in the electron volt. Okay, electron volts. So you know that if this energy is in joules, okay, and you need to convert it into electron volts. So you know that energy in electron volt, electron volt. Okay, electron volt means, what do you mean by electron volt? Means how many electrons are going to have this energy. Okay, got it? So what we are going to do is this one, that this total energy is equal to 10 power minus 22. We are just going to divide the energy of the electrons. And what is the energy of the electron volt? 1.6 into 10 power minus 19 coulombs. Okay, so we will divide this value with 19 point, then you will get the value in electron volt. Okay, got it?
Yes, sir.
No, you understood this
Ye-
one?
Yes.
Okay, so whatever the energy is in joules, if you want to convert it into electron volt, then you have to divide it 1.6 into 10 power minus 19. Okay, because electron is means electron is actually carrying the charge, and charge into potential difference, and Q into V is equals to energy. Okay, next is, it is being asked kilojoule. Next question is electron in kilojoule. Electron means energy in kilojoule. So what would be the energy in kilojoule? So whatever the value is, you have to divide it by thousands. Next, this will become, what should be the value? Tell me. You have to divide it by 1,000. What you will get when you divide it by 1,000? Tell me. Divide the upper value by 20 by 1,000. You will get 2.0 into 10 power minus 19 or 25. Tell me.
I didn't get what you asked.
Yes, you will get, you have to divide it 19.2. If you are just going to, you will be 25. Okay. But if the question is being asked kilojoule per mole, question is being asked kilojoule per mole. If the question is kilojoule, instead of per photon, it is per mole. Find the energy. Next is kilojoule per mole. So how many particles are there in 1 mole? How many particles are there in 1 mole? So if it in kilojoule, it will be 22.2, or we have 2.0. In joules, we have 2.0 into 10 power minus 22. Okay. And if you need to convert, it is in joules. And if you need to convert it into kilojoules, so you have to divide it kilojoules, so you have to divide it by 1,000. So you divide it by 1,000. Okay. Per mole. Per mole. So you have to divide it further by, and per mole it is saying, per mole means for 1 mole. The number of particle is given to you, that is per mole. So it is the energy of one particle. So if we have 1 mole particles, if we have, how many particles are there? 6.022 into 10 power 23. So you have to multiply this number 6.022 into 10 power 23. Okay, got it. So you cut this 0, you will get 20. Okay, and when you get 20, so you multiply this one, you will get 12 into 10 to the power minus 2. Okay, got it. This will
Yes.
be kilojoule per mole. Now you understood this one.
Yes, sir.
And kilocalorie per mole. If it is kilocalorie per mole. So you know that 1 joule is equals to, or we can say 4.2 calorie is equals to 1 joule. Okay. So you have to divide it by, so energy in joules is 2.20 times power minus 22. Now it is in kilocalorie per mole. So kilocalorie, okay, so you have to, whatever the energy is in kilojoule, so whatever the energy is in kilojoule, if you have to convert it in kilocalorie, so energy in kilojoule per mole is, 12 into 10 power minus 2. This is the energy in, joule, it is kilojoule per mole. And if you want to convert it into, kilocalorie per mole, so the relationship between calorie and kilo, so we can say that here 1 joule, 4.2 joule is equals to 1 calorie. Okay, 1 kilocalorie. Kilojoule is equals to 4.2 kilocalorie. Okay, so you have to divide it 2 into 10 power minus 22. Okay, divided by 4.2, whatever the answer comes, it will be the answer. Okay, got it?
Yes, sir.
2.85 into 10 power minus 2. Got it?
Yes, sir.
What is the frequency? Tell me the frequency. Frequency of the wave. Frequency is c by lambda. C into 10 power 8 upon 1 by lambda is, tell me what is 1 by lambda? 1 by lambda is wave number which is given to you 1000. Okay, so that would be 3 into 10 power 11 hertz. Okay,
Yes, sir.
next. What is the wavelength? Wavelength is the reciprocal of this one. Okay, so 1 by, what is wavelength? So wavelength is equals to 1 by wave number. So that is 1 by 1000. That is equals to 0.001 meter. Got it? Or 10 to the power minus 3 meter. You understood?
Yes, sir.
Now the question from NCERT. Find the number of photons of wave number of wavelength. Sorry. Of 60 watt. Find the number of photons which are emitted actually of wavelength 500 nanometers in 1 hour from the bulb, which means which are emitted by the bulb in 1 hour. Try to solve it. Number of photon you have to find out. Now I'm going to give you a hint. E is equals to, n is the number of photon into h nu. Lambda is given to hc lambda. Okay. And energy is equals to, what is power? What is the power? Okay, so we can say that energy is equals to, yeah, we can say energy is also equals to work done. Work done is equals to power into time. Okay, so tell me, how will you do this one? So we can say here that power is equals to work done upon time, and work done is work done. Let we have 60 watt here. Okay, 60 watt power is given to you, and for the time 1 second. So we can say that work done per second is actually, or we can say work done or energy per second utilized is 60 joule. Got it? Got it?
Yes, sir.
Means for every second the bulb is consuming 60 joule energy. Okay. So for in an hour, it will consume the total energy consumed in an hour is equals to 60 into 60 into 60. 60 for 1 second, and total number of second in 1 hour is 60 into 60 is equals to 21600 joules. Got it? So is equals to 21600 is equals to N. What is N? You need to calculate. H is 6.6 into 10 to power minus 34 into 3 into 10 to power 8 upon wavelength is 500 nanometers. So you have to convert it into meters. So you know 1 nanometer is equals to 10 raised to the power minus 9 meter. So if you need this 500, so you have to multiply this one 500 nanometer is equals to 500 into 10 to power minus 9 meter. So 2 decimal will shift here. So we'll get 5 into 10 to power minus 7. You understood?
Yes, sir.
Okay, then tell me what's the answer. And you know that we have given you a formula. If the wavelength is in angstrom, okay, 10 to power minus 10 form, then we have a formula that energy is equals to, we have multiplied this one and we have N into 2 into 10 to power minus 15 upon wavelength if the wavelength is in angstrom. So you know that angstrom is 10 to power minus 10. Okay, 10 to power minus 10. So we can write that E is equals to N into 2 into 10 to power minus 15, 2 into 10 to the power minus 15, and 1 angstrom wavelength. So if it is 500 in nanometer, means it is 500. I can write it 5 into 10 to the power minus 9. So if I write it into 10 to the power minus 9, 10, so I have to write here like this. The same thing is can be written like this. You understood? Got it? When I
Yes, sir.
increase 1 power minus here, then here 1 0 will be increased. Got it? And you know this is 1 angstrom. So instead of angstrom, you can write it 5000, means 10 to the power minus 10 because it is an angstrom. So 10 to the power minus 10 is 1 angstrom. Okay. Got it?
Yes, sir.
So you can write it 216 into 10 to the power 3 is equals to, or you can solve it like this for research wise. Okay, here you can write it N into 2 into 10 to the power minus 15 upon 5000. Now calculate the value of N. Done? What's the answer? No? No. Are you
1
there?
minute.
You are doing?
N is equals to 432 into 10 raised to 21.
What are you saying? How much?
432 into 10 raised to 21.
It would be total number of you have calculated na in an hour. Okay. S- So it is 200 approximate. Assume that for approximation, you can write it like this way. 216, you can take it 200. Instead of 216, take 200 into 10 to the power 3 is equals to 2 into 10 to the power 15 into n divided by 5000. Okay, you understood? Now, this when multiplied, this 2 will get cancelled out, it will be 100. This is 10 to the power 5. 10 to the power 5 is equals to 10 to the power 15, okay, into n upon 5000. So when you this will goes down, how the number of particles can be in negative power? It is not possible. No, it is not. It is not in the negative number. This is the positive number. Okay. So when you divide it, it will goes to 10 is to the power 5 into 10 is to the power 8 upon 10 is to the power minus 15 is equals to n. So it will goes up 5 into 10 is to the power, okay, 33. Sorry, not 33, 23. This is the answer. Okay,
Yes, sir.
on an approx. Next, if we have a next question here, a bulb rated 150 watt emits 8% of its energy in the form of visible light of wavelength 450 angstrom. Find number of photons emitted by the bulb in 1 second. Do it by yourself. Are you doing this one?
Yes, sir.
8% means whatever the energy you are, means it is emitting. Okay, take that energy 8% only. Okay. So 150 watt if it is rated, so it means that it is releasing, it is taking 150 joules per seconds energy. Okay. So only 8% of 150 you have to take. Okay. That is the
Okay, sir.
total energy. And according to that, you have to calculate its value. Okay. Sorry, you have to calculate the number of photons, whatever it is being asked. Done?
1 mil.
Okay. Done? Uh-huh. Are you there?
Yes, sir.
Done?
I'm doing the last step.
You are calculating the last part.
Yes.
Are you taking the long way? Because this is just 2 or 3 steps question.
It's 27 into 10 raised to 16.
10 raised to 16.
Yes.
It is 27 10 to the power 18. So let's check. Energy is equals to number of photons into E, and each means each energy of each photon we are talking about. So here it is 150 watt. So total energy emits energy emitted by per seconds. Per second. So it will be 150 into 8% of this one. 8% energy which is visible as of wavelength is given to you in angstrom. So use the formula of angstrom and joules. Okay. So energy is in joules. Okay. So what's the formula for this one is 2 into 10 to the power 15. 2 into 10 to the power minus 15 upon number of photon. Okay. Energy is equals to, if it is in joules, okay, and it is 2 into 10 to the power minus 15 upon into number of photons upon wavelength in angstrom. Okay, so that would be 4500. Got it? So now this 20 and this 20 will get cancelled out each other. Okay. Now this 15 will comes down. Here it will be 150 into 8 upon 2 into 10 to the power minus 15 is equals to n. Got it?
Yes, sir.
So when you multiply these two, how much you will get? 120 when you multiply this one and 515 and 10 this one. This is 1200. Okay, then 1200 when divided by this one, you will get 600. Okay, are you getting?
Yes, sir.
And this is 45 here also. So this 45 is going to multiply with this one also. So 6 into 45 upon this 10 to the power minus 2. This will be 10 to the power minus 17 plus 17. Why? Because 20 from this one and 15 from this one. It will be 17. Okay, is equals to n. Got it? When you multiply these two, so we'll get 275 into 10 to the power 17. Wait a minute. 270, not 70. 270. 270, not 75. So when you put this one, the decimal is positive, power is positive. So when it is in standard form, you will write it 2.70 into 10 raised to the power positive 19. Okay, or 19. This one is the answer. Got it?
Yes,
You
sir.
understood this one? Okay. Let's do the next question. It is closure in per mole. This is also a type of question that is being asked. The bond dissociation energy. Bond dissociation energy of I2. I2 is 240 kilojoule per mole. Okay, 240 kilojoule per mole. This is the energy kilojoule per mole. Okay, find the number of photon required to break one I2 molecule. To break one I2 molecules into iodine atoms. Into iodine atoms by wavelength of 5000 angstrom. Do this one. What is the question? Bond dissociation energy of iodine molecule. This is the iodine molecule. It is for one. If we have one mole of this one mole means 6.022 into 10 power 23. Such iodine molecules we have. So the amount of energy to break all the bonds will be 240 kilojoule per mole. 240 kilojoule. Okay. Find the number of photons required to break one I2 molecules. You have to find out one mole. Okay. So into the iodine atoms of wavelength of 500 angstrom. So we need to find out how much energy is being required to break this bond. Okay. In which the wavelength. So energy. So you need to find out the energy. Find out the number of photons. Actually, you need to find out the number of photons. So E is equals to, again, what you will write. So this is the energy required for breaking how many kilojoules of means how many atoms? 6.022 to the 10 to the 23. If we are just breaking only one, so if I break the energy, or if I calculate the energy required to break one I2 molecules, energy required to break one I2 molecule, is equals to how much it will be? Tell me. It will be, this is 240. First of all, convert it into joules. Okay, so this way 2400 joules, and per mole it is of actually energy for one mole atom. So if I need to find out of only one I2 molecule, so I have to divide it by 6.0 or 6.022 means 6.0 into 10 power 23. Okay, got it. So that would be 1, 2, 3, 4. You cut it like this way. The 40 will be cut here, 19. And you will divide it by 2, you will get 6 1 is 6, 6 4 is 24. So you will get 4 into 10 power minus 19 joules of energy will be required to convert. Okay, got it? You
Yes, sir.
understood? To break only one I2 atoms. Now you need to calculate the photons. So energy is equals to N if it is in joules and the wavelength is in angstrom. So you can write it, energy is equals to N into 2 into 10 to the power minus 15 upon, tell me, upon wavelength in angstrom. Now calculate the value of the number of photons.
5 into 10 raised to minus 11.
5 into
10 raised to minus 11.
Okay, let me check. So you have to write it. E is equals to E. You have calculated how much E? 4 into 10 to the power minus 19. So that is 4 into 10 raised to the power minus 19 is equals to 2 into 10 raised to the power minus, sorry, n into 10 to the power minus n into 10 raised to the power minus 15 upon, if it is in angstrom, it is 5000. Okay. To break one molecule of iodine into iodine atoms of fermentation. Now, this one going to multiply with this one. How much it will gives you? 10 into 2 into 10 to the power minus 15. And when it is going to multiply with this one, you will get 20 into 10 raised to the power 10 raised to the power. This 3 0 will get cancelled out here. So the 3 zeros when get cancelled out, you will get 10 to the power minus 16. Okay. And when you convert it into, when you write it like this way, so this can be written as 2 into 10 raised to the power. When you cut this 0, or even multiply this 10 from here, you will get 10 to the power minus 15 is equals to n into 10 to the power minus 15. Okay. This 10 to the power minus 15, this one will get cancelled out. Or you can bring this one here. So you get n is equals to 1. Number of photons, photon is equals to number of photon required is only 1. Is 1. Okay. You understood this one?
So write in E is equals to n into 2 into 10 raised to minus 15 by uh, 5000. Why didn't we multiply 10 raised to minus 10?
10 to the power minus 10 because it is the formula. Na? When angstrom is, when the wavelength is in angstrom, then we have to use this formula. This formula is basically coming from by solving these values. H is equals to E is equals to HC by lambda. Okay. H is 6.6 into 10 to the power minus 34 into C is 10 to the power minus 38. If the wavelength is in angstrom, so whatever it is given to you in meter. Okay. For example, if the wavelength is in angstrom, so whatever wavelength it is given to you, you have to write it 10 to the power 10. If it is in meter. Okay. So minus 10 here if it is in angstrom. Okay, got it. So when you solve this one, and then you will get, okay, 34 minus you will get 24, and 24 minus 8, and when you multiply this one 6.6, you will get approximately 18 point something, 18.8, sorry, 19.8, 19.8, and 19.88 is approximately equals to 2.0. So when you solve all this, you will get 2 into 10 to the power minus 15. But here wavelength should be in angstrom, okay, because we have just calculated this 10 to the power minus 10. Okay,
Yes.
in our problems. You understood properly?
Yes, sir.
This is in NCRT also, so not in. Next question. We are just going to have the Bohr model, okay, and Bohr model will be the next part of this one because it is an important part. So Bohr model of atoms and Bohr. So we're going to study this one.